Hi everyone. So I am going to evaluate 2023 first term physics Wezary exam questions. First, let's check the questions in general. What kind of questions are asked in Ministry Wezary 2023, the first term? From 50 questions, 10 questions were repeated questions. The questions which are asked in the previous years, asked again. 12 questions were modified, which means the previous last questions are changed very little and then asked again. 28 questions were new questions, which are from the book, in fact, not from outside books. In general, if I talk about the 2023 first term physics exam, it was easier than the last year's first term exam. And when I check both exams, I see that this year's are the difficulty level of the questions were easier compared to last year's ministry exam. Again, conceptual and then definitions, 25 questions. Problems, 25 problems are in ministry 2020 first term physics exam. And when we check the questions, distribution of the questions to the chapters, 6 questions were from chapter 1, 6 questions were from chapter 2, 6 from chapter 3. So 5 from chapter 4, 6 from chapter 5, 10 from chapter 6, 4 from chapter 7, and 4 from chapter 8, 3 from chapter 9. So the above was my expectation before the ministry exam, and the below is how it happens. And in fact, these numbers almost the same in every year. 1 plus 1 minus 1, it can change, but not so much. And from when we check that, chapter 6, 10 questions, and from 5 questions, one of them was from chapter 5. Now let's continue with the questions. Question number 1 is, in fact, it's a modified question. And this question is asked in ministry before. The same statement, same form, but what is asked, it changed. Previous years, maybe they asked delta t, but this time they give delta t and ask the average angular speed. A car side rotates an initial angular speed of 21 radian per second, 21.5 radian per second, which is omega initial. A driver accelerates, and after 2.5 seconds, which is delta t, the tire's angular speed becomes 28. And this question is, in fact, exactly the same question in the book. Even they didn't change, I think, the number, or slightly changed. Omega final. What is the tire's average angular speed acceleration? Alpha is the question in this problem. So we will use the definition of the angular acceleration, which is omega final minus omega initial divided by delta t. So omega final is 28 minus 21.5 divided by delta t, which is 6.5 seconds. So let's use the calculator. 28 minus 21.5 divided by 6.5. Yes, same as it's the 1. Yeah, it's the 1 radian per second squared. So as you see, answer is A for this question. Question number 2 is, we have a similar question in the book. This is the first time asked question, not asked before, the first time. The weight of the mass of the person changed. Chapter 1, section 3 question is this. So find the magnitude of the gravitational force of 71.2 kilogram person would experience while standing on the surface of the planet Earth. So if somebody stays on the surface of the planet, any planet, can be or Earth or Mars or Moon, wherever you are. So mass of the man is 71.2 kilogram. Mass of the planet is considered to be accumulated, concentrated at the center, which is I will represent by capital M. Capital M is given as 5. It's written there, no need to write again. This is capital M, I write it, this is small m. And the separation between these two object masses is the radius of the planet, which is also given r. So gravitational force acting on the man's body, Fg. We are going to use Newton's law of universal gravitation. Fg is equal to capital G, mass of man times mass of planet divided by square of the radius of the planet. So G is 6.67 times 10 to the power of negative 11 times mass of Mars 71.2 times mass of planet is 5.98 times 10 to the power of 24 divided by r squared 6.37 times 10 to the power of 6 squared. So Fg is going to be, in this case, please calculate 6.67 times 10 to the power of negative 11 times 71.2 times 5.98 times 10 to the power of 24 equals this number divided by in 6.37 times 10 to the power of 6, but squared. Answer is almost 700, and this result is 700 Newton. So correct choice is D. Question number 3, modified, and such questions are in ministry several times. How many radian are equal to 35 degrees? You can go definition of the radian, you can go the equation in the book. The way how you calculate is can change. So I will go with definition of the radian. 1 radian is equal to 57.3 degrees. So 35 degrees is equal to how many radians? So on the cross multiplication. So x times 57.3 is going to be 1 times 35. So divide by 57.3, divide by 57.3, we can calculate answer. 35 divided by 57.3, answer is 0.61. 0.61, this is one of the sectional questions I remember. In the book, it was 35, I think, radian. So C is the correct answer for this. And question number 4, the angle between the direction of the centripetal force Fc and tangential velocity Vt is equal to 90. This is a repeated question. This question is asked in 2017, 19, 20, and 2023, and 4 times. So angle between centripetal and tangential, whatever it is, centripetal or tangential velocity, centripetal or tangential acceleration. So angle between the centripetal is the on the radius, and radial, sometimes called radial. Tangential, tangent and radius perpendicular to each other, and 90 degree angle between them is 90 degree. The B is the correct answer. A car is moving in a circular path with constant tangential speed. If tangential speed is constant, at 0, tangential acceleration is 0, because tangential acceleration happens if tangential speed increases or decreases. Move in a circular path always produces AC. Yani AC is not 0, because object moves in a circular path, its direction changes. Because of the direction change, there is going to be centripetal acceleration, of course. But because of constant tangential speed, at is 0. Which of the following is true for the motion of the car? It has tangential acceleration. No, this is not correct. So we cancel this. It has a centripetal acceleration, yes, but no tangential acceleration. This is correct. It both centripetal, no. It doesn't have tangential, no. So this is B is the correct answer for this question. This question is new, the first time asked question. In fact, one of the chapter 2 question. It's not in the form of the multiple choice, but there was a chapter 2 question. If an object moves in a circular path with a constant tangential speed, so will it have this or that? They are asking such question in one of the chapter 2 questions. Question number 6. A car is moving flat circular track. Identify the force that maintains circular motion. When an object moves in a circular track, flat and horizontal. And if a object is moving on a horizontal surface in a circular path, so absolutely the friction force between this object and the road is going, or surface is going to be the centripetal force. Yani friction force between the tires and the road is going to be centripetal force. Total weight is vertical. It is not effective. It cannot point in center. Normal is vertical also. It cannot point center, not effective. So only A is correct answer. This is also modified because these questions are in several devices, sometimes bicycle, sometimes motorcycle, and or track, it doesn't matter. So flat circular track, when it says the flat horizontal contact surface in a horizontal circle, so force of friction between the tires and the road is going to be the centripetal force, which provides centripetal motion, circular motion. Question number 7. The three forces acting on the road have equal magnitudes, F1, F2, F3, 10 Newton, as shown in the figure, which are the forces produce greatest torque on the road about axis at the left and the road. First, note that F3 is acting on axis of rotation. If a force acts on axis of rotation, its torque is 0. Yani, torque 3 is 0. So that's why we cannot include F3. F3 is not going to be in the our calculation. But F2 and F1. So let's calculate torque for F2. Torque 2 is, because we just care about its magnitude, the greatest torque, it's equal to F2 times d times sine theta, d2 times sine theta. F2 is 10 Newton, all are 10 Newton. Distance from F2 to axis of rotation, d over 4, because length is 1, this length is 1 meter. So 1 over 4, and 0.25 meter is going to be distance for F2. So 0.25, because it is d over L over 2, it becomes 1 L over 4, it becomes 1 over 4. 1 over 4 is 0.25. So 0.25 meter times angle is, because angle is 90, sine 90 is 1, no need to write it. Answer is going to be 2.5 Newton meter. So torque 1, let's check torque 1. It is F1 times d1 times sine theta 1. So F is again same, they have all equal in magnitude, but distance for F1 is from where the force acts until the axis of rotation, it is 1 meter, yani L. Angle is 30, sine of 30, we have to write it. Angle between the force line and the distance line is 30. So sine 30 is 1 over 2, and 0.5, the result is going to be 5 Newton meter. As you see, torque 1 is greater than torque 2. Yeah, which one produces the greatest torque? Of course, F1 produces the greatest torque. It's certain that F1 produces the greatest torque in this problem. So I did here some spelling mistakes in the calculations. Okay, next question. Two solid spheres of different diameters and different masses have the same moment inertia. If the diameter of the second sphere is the half of the diameter of the first sphere, and the mass of the second sphere is how many times of the first sphere? So there are two spheres. I am going to now indicate them, first and second spheres. So question says that diameter of the second sphere is half of the diameter of the first sphere. So if I say that first sphere diameter is 2d, second sphere is going to be half of 2d, which is d. And also I know that in moment inertia equation we use not diameter radius. Diameters and radius are directly proportional for a sphere. And if I say first sphere's diameter radius 2r, second sphere's radius is going to be r. Yeah, and let's write them. First sphere radius I will write 2r. Second sphere radius is going to be r. And they have the same moment of inertia. First sphere radius mass and second sphere's mass are not equal. The questions about that. The mass of the second sphere is how many times of the first sphere? But I know that they have equal moment of inertia. So let's write their moment inertia equation. For the first sphere, it is 2 over 5 m1 2r squared. This is the moment of inertia of the first sphere, must be equal to moment of inertia of the second square. Question says that they have the same moment of inertia, yani 2 over 5 m2 times r squared. So let's simplify. 2 over 5 will simplify. So when I squared this m1 times, no, not in here, let's continue right there. From here, let's continue. m1 times 2r. When I get the square of 2r, I had to square 2 and r. Square of 2 is 4. Square of r is r squared is equal to m2 times r squared. Again, now I can simplify this r squared. They also simplify. What is left? m1 times 4 is going to be m2. Question says that mass of the second sphere is how many times of mass of the first square? As you see, m2 is 4 times of m1. Yani mass of the second sphere, yes, is 4 times of the mass of the first sphere. So C is the correct answer. Question number 9. A solid ball starts from rest at the top of 3.5 meter height. H is given. Find the translational speed, which is Vt is the question, after it has rolled to the bottom of the incline. It's a solid ball. For solid ball, we have moment inertia equation 2 over 5 mr squared. And coefficient of moment inertia is 2 for this. What is this translational speed at the bottom? I'm going to use the equation which I used in the classroom, Heck equation. Vt is equal to 2gh divided by c plus 1. C is the moment inertia. So after that, you are going to insert the numbers. 2 times 9.81 times h is 3.5 divided by c plus 1, which is 2 over 5, 0.4 plus 1. This is 2 over 5. After that, we are going to use the calculator. 2 times 9.81 times 3.5 is 68.67 divided by 1.449. When we take the root, it's going to be 7. Yes, translational speed is going to be 7 meters per second. Yes, this is also one of the similar questions we have in the book. In the ministry before it's asked similar question. They asked not translational, angular speed. After you calculate translational speed, when you divide it r, you will calculate the angular speed. They asked this one, but this time they didn't ask angular speed, they asked the translational speed. Also, question number 8 is the first time asked such a question. Yes, 8. It's in fact it's a kind of mathematics. If you're mathematics, it's kind of question number 8. Question number 10 is a question several times asked, 2014, 15, 16, 23. These numbers are changing. In the ministry, most probably this number is not our number in the ministry because I copy paste. So this number can be different. So I'm going to check it if this number is correct number or not. Yeah, it is not that number. Number is changed. Choices are also changed. I forgot to change the choices because this question several times asked ministry. I didn't change the number. That's why I went with the current number, 1000. Instead of 1000, they put this time 720. Okay, I will continue with 1000, and instead of 1000, you will write 720. Then you can get it. So a man of weight is 1000 meters stands on a light board. When it says light board means mass is 0. You will neglect the mass, and that's why gravitational force is 0. Length is 2 meters fixed on 2 supports. So I'm going to draw a 2 meter long board. This is 2 meters long board. And let's indicate the distance to 2 meters from one end to the other end. It's the length of the board. It's fixed on 2 support at extremities, ends. One support is at one end, other support is at the other end. And there is someone on this light board. If the distance between the point where the man stands and the first support, so you should label first and second. This one I will say first, this one I will say second. The man is 0.5 meter from the first support, so I am going to indicate a distance, which is 0.5 meter. This is, I will say that 0.5 meter. We use blue color for this. 0.5 meter. So from first of all 0.5 meter away, there is someone standing on the board. This person, of course, will be acting a force, gravitational force on the board, Fg, which is 1000 Newton. Find the force exerted by the first support on the board. So, of course, each support acts a force on the board. First support acts Fn1, the normal force 1. Second support as Fn2, which is normal force 2. So calculate Fn1 is the question. If you are going to calculate Fn1, you should choose the other force position as axis of rotation. And after that, according to this axis of rotation, Fg produces a negative torque, but Fn1 produces a positive torque. So calculate these torques one by one. So torque of G is negative Fg 1000 times distance from Fg to axis of rotation is going to be 2 minus 0.5, which is going to be 1.5 meter. Right here 1.5. Angles are 90 because perpendicular force, horizontal contact surface. So it's going to be negative 1500 Newton meter. This is torque of G. So calculate torque of Fn1. Torque of N1, I will write that. It's positive. Fn1 times distance from force to axis of rotation is length of the board, which is 2 meter. Angle is 90, sine 90 is 1. So that's all. Fn2 produces 0 torque. Torque of N2 is 0 because it's acting on axis of rotation. Net torque, sum of the torque acting on the board object must be equal to 0. So we will add them. Torque of N2 plus torque of G plus torque of N1, 0. Torque of N2 is 0. Torque of G is negative 1500. Torque of N1 is positive. 2 times of Fn1 is equal to 0. Transfer to the other side of the positive, divide by 2. So when you do that, Fn1 is going to be half of 1500. It's going to be 7,750 newtons. Yani numbers will change. Of course, choices will change in this case, but how we solve the problem is the same as the previous problems. Question number 11. Ice skaters use the principle of conservation of angular momentum to produce high-speed spins. If the skater's moment inertia decreases to half, by what factor does its rotational kinetic energy change? So we know that for ice skaters, because they are spinning on ice, their angular momentum stays unchanged and conserved because friction is almost neglected. That's why I and omega inversely proportional. And if, according to the question, because moment of inertia decreased by 2, it's halved. So if I change it by decrease by 2, to get the same angular momentum, angular speed must double. So these two will simplify, and then you are going to get again same result. Yani, if initially we have initial case before changing the moment of inertia and after changing moment of inertia. So initially moment of inertia is I, angular speed is omega, but after that, after final cases, I changes to I over 2. But because moment inertia is half, to keep the angular momentum constant, angular speed doubles. So initial rotational kinetic energy, I am going to write kinetic energy initial, it is 1 over 2 I omega squared. A final rotational kinetic energy is 1 over 2 I over 2, because I changed I over 2, 2 omega squared, because omega changed to 2 omega. So I will continue. 1 over 2 I over 2, I have to square 2 omega, I have to square 2 and omega, both of them. Square of 2 is 4. Square of omega, omega squared. After that, let's simplify this 4 and 2. This is going to be 2. After that, take this 2 in front of the equation, write it 2 times the left 1 over 2 I omega squared is left. This is initial rotational kinetic energy. Yani rotational kinetic energy final is going to be 2 times of kinetic energy rotational initial. So it becomes twice. As a rule, maybe you can go in only these types of question. By what factor omega changes in these types of question and ice skater problems? Rotational kinetic energy also changes the same factor. This is the one of the chapter 2 question. It is asked as a multiple choice in the first time in ministry. Question number 12. It's a modified question, and this question is asked in ministry, the same structure but little change, modified. A force of magnitude 12 Newton, which is F, applied tangentially to a disk of radius 0.2. If the angular acceleration of the disk 4 radian per second square, which is alpha, what is the moment of inertia of the disk? I is the question. So I'm going to use two definitions of torque in this problem. One definition is torque is produced by a force over a lever arm, F times D sine theta, and this torque causes an acceleration Newton's second law for rotational motion I times alpha. Yani I'm going to combine two equations. One of them is definition of the torque, Ft sine theta, which is the origin of the torque. Second one is what torque causes, I times alpha. So they are equal to each other. I will make them equal. Of course, when force is tangentially applied to a disk, so it's rotated about its center. This center is going to have axis of rotation. Distance is going to be radius, and angle, because it's applied tangentially, angle is going to be 90 to the radius or distance. So after that, F times D instead of the I am going to write, R is going to be equal to I times alpha. F is 12, radius is 0.2, I is the question, alpha is given in the question as 4. The rest is simplify 4 to get I. So I is going to be 12 times 0.2 divided by 4, result is 0.6. 0.6 kilogram meter squared, yani A is the correct answer. Question number 13. Which letter on the graph is used for wave amplitude? Amplitude, remember, is the distance from equilibrium to the crest or from equilibrium to trough, that distance. In this problem, it is D. D is representing amplitude. This is also a new question, the first time asked question in ministry in this form. Question number 13. Two tuning forks are stuck. The first produces sound with a frequency, so let's say F1, with a wavelength which is lambda 1. Second fork produces a frequency, say F2. What is the wavelength of the second one, and what is lambda 2? So we know that for a mechanical wave, both are mechanical waves, sound, they travel in the same medium. If they travel in the same medium, they have equal speeds. So, yani V1 and V2 are equal. They have equal speeds because they are in the same medium. Same medium. It was the rule. So, V1 is lambda 1, F1. V2 is lambda 2, F2. So they are equal to each other. Lambda 1 is 1.2 meter. F1 is 285. Lambda 2 is the question. F2 is 570. Simplify 570 by dividing both sides, 570. So find the answer. Lambda 2 is going to be, use the calculator, 1.2 times 285 divided by 750, 0.6. 0.6 meters is the wavelength of the second wave. B is the correct choice. Question number 15. If a pendulum is made with a bowl filled with water, a pendulum is made with a bowl filled with water. If a hole in the bowl allowed water to slowly leak out, which of the following is true? So, frequency of the pendulum increases, frequency doesn't change, period of the pendulum does not change. We know that period of simple pendulum just depends on 2 pi root of length of the pendulum divided by free fall acceleration. And period of simple pendulum is independent of mass, because when the water slowly leaks out, mass decreases. But we know that mass does not affect the period. So period of the pendulum does not change, correct. But if period does not change, frequency also does not change, because period frequency is equal to 1 over period. So same is also same. So frequency does not change. So B and C are correct answer. Correct choice is going to be D. This is one of the chapter 2 question also of chapter 3. Two waves with equal amplitudes interfere constructively. If the amplitude of the resultant wave is 84 centimeters, then the amplitude of each wave. Yes, this question is modified, and number is changed only. That's why I didn't put the 2023 question in here. This is the previous one. But instead of, I think, 84, they put 72 or something like this. That's why there's no big difference. So if the amplitudes are equal, say the amplitude is A plus, because they constructed interval, we add the amplitudes A, total is going to be 84. So 2A is going to be 84. A is going to be, when we divide by 2, 42 centimeter. So 42 centimeters is going to be 0.42 meters. So this is the correct choice. I think in 2023 they give all the centimeters. You don't need to convert this meter. It was much easier than this one. Question number 17. Omega C is equal to what? We remember omega C. We remember 1 over omega C. 1 over omega C is XC. Remember, capacitive impedance. So when we flip both sides, because it means if 1 over omega C is equal to XC over 1, flip both sides, omega C becomes 1 over XC. So 1 over XC, B is the correct choice. Question number 18. A simple pendulum is moving with a simple harmonic motion, disregarding the friction and the resistance. Which of the following remains constant for the bob pendulum along the circulating motion, oscillating motion? Gravitational potential energy, kinetic energy, restoring force. They are all changing. Gravitational potential energy decreases as approaching to the equilibrium position. Kinetic energy increases. Restoring force changes according to theta amplitude. But total mechanical energy stays unchanged if we disregard friction and air resistance effect. And if you neglect the friction and air resistance, total mechanical energy, which is the sum of kinetic energy and potential energy, mechanical energy, stays constant. So this is A is the correct answer. Which of the following is true for audible waves, infrasonic waves, and ultrasonic waves in the same medium? Keyword same medium, which means they have the same speed. Same speed. So let's get the frequencies, because we know that frequency of the ultrasonic wave is the highest, audible is higher, infrasonic is smallest. Frequency case, B, audible is less than infrasonic. Frequency of the audible is greater. It must be greater like this. So that's why this is not correct. Frequency of audible is greater than infrasonic. Yes. Frequency of audible frequency is greater than infrasonic. This is correct. And answer choice seems to be D, but let's check other two choices. Lambda audible is less than ultrasonic. So because frequency of audible is less than frequency of ultrasonic, so lambda audible must be greater than, they're inverse proportional, greater than lambda ultrasonic. So this is not correct. Lambda audible, lambda ultrasonic, no, they cannot be equal. That's why only correct answer in here is D. A Formula One race car moves with respect to observer. If the observer hears the sound of its engine, 20% reduction of its original frequency, which of the following is correct? Yani reduction means pitch frequency is less than original frequency. Yani this is a case of moving away. Yani source and observer relatively moving away from each other. So A, observer and car are at rest with respect to each other? No. Observer is moving towards the car? No, they don't move towards the car. They must move relatively away from each other. The car is moving towards the observer? No. The car is moving away. Yani away. One of them must move away or both of them must move away from each other. So D is correct choice. Which figure indicates the speed of the plane attains the speed of sound? When the speed of the plane and speed of sound are equal, we know that plane produces compressions and waveform compressions, but these compressions moves at the same speed with the plane. That's why this compression accumulate in front of the plane, just in front of the plane and in here. So second case. First case is airplane, plane must be less than speed of sound. Second one is, yes, as we said, speed of the plane must be equal to speed of sound. A third one, if speed of the plane is greater than speed of sound. So in this case, shockwave forms at the edge and sides of the airplane. So correct answer is 2 for this question. If the longest wavelength of a standing wave or pipe open at both ends is 4.5 meter, what will be the longest wavelength of the pipe when one end is closed? Yani for open pipe, longest wavelength lambda 1 is 4.5 meter. Question says that if this is closed, yani everything else is the same, just we're going to make one end closed. What is going to be lambda 1? So we know that for open pipe, wavelength which produces standing wave is calculated by equation lambda n is equal to 2L over n. But for closed end pipe, it's 4L over n. Yani for the first harmonic, yani the longest wavelength, which is the first harmonic, lambda 1 is equal to 2L. For closed one, lambda 1 is equal to 4L. As you see, wavelength of the closed one is twice of the open one. Open one is 4.5. Yani this is lambda 1 is 4.5 meters for open. So for closed, lambda 1 must be twice of that number, yani 9 meters. As frequency of wavelength doubles when you close the one end of a pipe. Baseball coach shouts an umpire standing 5 meters away. This is the distance. We represent R as an R. If the sound power produced by the coach is this number, which is P, what is decibel level? Beta. Of course, before calculating beta, you should calculate first what is the sound intensity, which is power divided by 4 pi r squared. Power is 3.14 times 10 to the power of negative 3 divided by 4 times 3.14 times reduce 5 squared. These 3.14s will simplify. We are going to use the calculator. So 10 to the power of negative 3 divided by 4 times 5 squared, which is 25. Answer is 10 to the power negative 5. Yani sound intensity is 10 to the power negative 5 watt per meter square. Let's calculate the relative intensity beta, which is 10 log I over IO. 10 log I is 10 to the power of negative 5. IO, which is the softest sound, 10 to the power negative 12. So we are going to calculate it. When we calculate this, it's going to be, I think, 70 decibel. Yani this is the correct answer. 24 is the first time such a question in history. Suppose that Q1, Q2, Q3, Q4, 4 charges, each is moving in circular path in a magnetic field as shown in the figure. Which of them is positive charge? So let's check them. Q1. Q1 is inside a cross magnetic field. It's counterclockwise. So in fact, there's a short way for this. Cross, yani if I make a table, magnetic field and charge type, the magnetic field cross and charge is positive, or magnetic field dot, charge is negative. So they are, I say them similars. They produce counterclockwise rotation, so or circulation. But if magnetic field is cross, charge is negative. If magnetic field is dot, charge is positive. Yani unsimilars clockwise. This is always correct. So now let's check the first one, Q1. Q1, it is counterclockwise, yes, this case, and magnetic field is cross. So charge must be positive. Yani Q1 is positive, absolutely. Q2, counterclockwise, magnetic field is dot, charge must be negative. Q3, clockwise, yes, magnetic field is cross, charge must be negative. Q4, clockwise, magnetic field is dot, charge must be positive. Yani Q1 and Q4 in here seems to be positive according to this table. And this table is always correct. Question number 25. An electric current traverses a one lobe of circular coil of diameter 50 centimeters. Calculate the current if the magnetic field at the center of the coil is 2 pi times 10 to the power negative 5 Tesla. And this is also modified, very short, small, even repeated, just that number has changed. So they give, I think, pi in the previous question. Yeah, several times that's such a question. It's a loop magnetic field. B is equal to, we know that, mu I, because it is one loop, no need to write n, divided by 2r, which is the diameter, in fact. We will find current, so I am going to write equation mu over 2 pi times I. I will find I, so that's why I have to transfer mu over 2 pi on the other side by flipping. So I is going to be B times 2r, sorry, 2r divided by mu. So 50 centimeters diameter, which is 2r. But it must be, of course, in centimeter, it's 0.5. Yeah, instead of 2r, I'm going to write 0.5 meter. So then I will be, B is 2 pi times 10 to the power negative 5. 2r is 0.5 divided by mu 4 pi times 10 to the power of negative 7. So 5 will simplify. After that, you go on with calculator. 2 times 10 to the power of negative 5 times 0.5 divided by bracket 4 times 10 to the power of negative 7, close the bracket. Answer is 25. So electric current is 25 ampere. Question number 26. As soon as I check the question, I see this Newton times second divided by coulomb times meter. This is a question's flipped version of that. Newton divided by coulomb per second times meter. So Newton is force. Coulomb per second is ampere. It's ampere in fact. Ampere version. In the 11th grade you learned that. Coulomb per second ampere. Ampere is electric current. M is length. And this equation is coming from the equation F is equal to BIL. If you write B alone, it becomes F over IL. Yani result of this, and this is going to be, or this is going to be unit of magnetic field, which is Tesla. Tesla. Yani A is the correct answer. A straight segment of wire has a length of 25 centimeter, which is L. Carries a current of 5 ampere, which is I. If the wire is perpendicular to magnetic field, maximum magnetic force, B is 0.6 Tesla. Find force. So just use the BIL equation. So force is equal to B is 0.6, I is 5, L is 25 centimeter, 0.25 meter. Multiply them all. 0.6 times 5 times 0.25. Result is 0.75 Newton. C is the correct answer. Question number 20 is a repeated question. It's definition of galvanometer. It measures very low current from microampere to milliampere. C is the correct answer. Which of the following equations is used to measure the strength of the magnetic field due to the direct current in the solenoid? In our equation of the magnetic field of solenoid, mu in over L length. So mu in over L is B. Question number 30. In the corresponding figure, calculate the conversion ratio, which can be N2 over N1 or V2 over V1. And also what type of transformer is it? So if N2 is greater than N1 or V2 is greater than V1, it is step up. So because as you see V2 is greater than V1, it's step up, absolute step up transformer. So this cannot be answered. Let's get the conversion ratio, V2 over V1, 3600 divided by 120. So let's divide it, 360 divided by 12. It's 30 over 1. So 30 over 1 step up transformer. 30 over 1 step up transformer is the answer. B is the correct answer. Question number 31. A power station sends a power to a city. If the transfer efficiency is 0.95, so what is the power sent if the power lost in the conducting wire is 50 kilowatt? So we know that efficiency, transfer efficiency is power received divided by power sent. In here the power lost is given in this question, but in here as you see no power sent. We can go in the opposite way. If transfer efficiency is 0.95, what power is lost? What percent is lost? 0.05%, because some of them is going to be 1. So 0.05% is power lost. Why don't we use this power lost percentage of power loss because it's given in the question. So efficient of the ratio or percentage of lost power, percentage of lost power is equal to power loss divided by power sent. This is much easier compared to the other way. Percentage of the lost power is 0.05. Lost power is given in the question as 50 kilowatt. So calculate power sent. And when we transfer 0.05 on the other side of the equation, so it's going to be 50 divided by 0.05. Power sent is going to be, I think, 500 kilowatt. When we convert it to megawatt, it becomes 5 megawatt. 5 megawatt is the, 1 megawatt, sorry. 50 divided by 0.05, 1000 kilowatt, or the 1, it's 1 megawatt is the correct answer. 32. Lenz's law determines which are the following: magnitude of the induced current, magnitude of the induced EMF, direction of the induced current. Definition of Lenz's law. The symbol M in the equation, mu delta L over delta I over delta T, this is mutual inductance. This M is called coefficient of mutual induction. B. 34. A generator coil has 400 turns, which is N, area, which is 0.3 meters squared, is rotating in uniform magnetic field and of the strength, which is B. If the loop's axis rotation is perpendicular to uniform magnetic field, so maximum EMF induced is E max is given. Calculate F. F is the question. All right, now we can continue with E max equation. E max equation is equal to BAN omega, but frequency, we should write omega by 2 pi f because frequency is the question. So I'm going to simplify BAN 2 pi, BAN 2 pi. So then get f, BAN 2 pi. Then let's continue. Frequency is going to be E max divided by BAN 2 pi. E max is 120 volt. B is 0.029. Area is 0.3. N is 40. 2 pi is 6.28. So let's do the calculator. 120 divided by, in bracket, 0.029 times 0.3 times 40 times 6.28, close the bracket. Answer is almost 55. Frequency is 55 Hertz. B is the correct answer. A generator with maximum output EMF, V max, is connected to a resistor which is R or 115 ohm. Calculate RMS current, I effective, the question. So let's calculate I max first by using the Ohm's law, Vm over R. So Vm is 205 divided by R, 115. This is I maximum. 115 divided by, 205 divided by 115. Answer is 1.78. Ampere is the maximum current. Effective current is question. Im divided by root of 2, which is going to be divided by root of 2, 1.26. Ampere is the answer. B is the correct choice for this question. Next question, question number 36. AC circuit made up of a resistor, which is R, self-inductor, which is L, and capacitor C are connected in series. What is the angle of the phase difference between the current and total potential difference if the circuit is resonant? In resonance cases, phase angle difference is 0 between the current and total potential difference, so A is correct answer. A mass of 600 grams attached to a vertical spring stretches the spring 3 cm from its original equilibrium position. What is the approximate value of the spring constant? K is the question. So when we suspend an object from a spring, so this is the unstretched spring, after you suspend it, it stretches because of course, gravitational force of this mass, which is Fg. Mass is 600 grams, which is 0.6 kilogram. Stretching, which is x, in the question is given 3 centimeter or 0.03 meters. Fg must be calculated, which is m times g, 0.6 times 9.81. So let's calculate how much is Fg. 0.6 times 9.81 is 5.88 and 5.9. Fg is almost 5.9 Newton. So then K is going to be F applied divided by stretching. F applied is 5.9 divided by 0.03. 0.03, answer is 196.2 Newton meter, which is going to be choice C, Newton divided by meter. Which one of the following is not essential component of a DC electric generator? So magnet, brushes, commutator, they are the elements of DC, but two slip strings, element of AC generator, so not DC is D. A coil of self-inductance 50 millihenry serviced by the current of intensity 2 ampere under direct potential difference of 20 volt. What is self-impedance? XL. So if XL is calculated only for AC current, because XL equation, remember, it was 2 pi FL. So F means it's for AC only. Current must change, otherwise there's not going to be XL. XL is 0. XL is calculated 0 in direct current, only can be calculated for alternating current. 40. Light falls on two slits spaced 0.33 millimeter apart. Slit spacing or separation D. If the angle between the first dark fringe and the central maximum is 0.055, this is theta, what is the wavelength of the light? So between the first dark fringe and central maximum, path length difference, d sine theta, is lambda over 2. Half lambda, so in this case it becomes dark. And if path length difference is 0, central bright, 1 lambda, first bright, but half, and 0.5, first dark, 1.5, second dark, 2.5, third dark, it goes on like this. And lambda over 2. So we will find lambda cross product. So lambda is going to be 2d sine theta. So 2d is, we should convert millimeter to meter because choices are given in meter as you see. D is 0.33 millimeter. Every 1 millimeter is 10 to the power of negative 3. Meter times sine of angle 0.055 is calculated. 2 times 0.33 times 10 to the power of negative 3 times sine of 0.055. Result is 6.33 times 10 to the power of negative 7 meters. Yani C is the correct answer. So question number 41. If a double-slit experiment were performed underwater, how would the observed different interference pattern be affected and why. So it's about theta. Theta equation is d sine theta is equal to m lambda. Theta sine theta is equal to m times lambda over d if experiment done underwater. Speed of the light in water is small. So because frequency unchanged, so speed and wavelength are directly proportional. If speed gets smaller, wavelength gets smaller as well. So that's why theta decreases. Wavelength smaller, theta decreases. So decrease because wavelength gets shorter in water is correct answer. Question number 42. Which of the following determines the wavelength of the light produced by a laser? It is just one thing, composition of the active medium, yani types of the molecules. So type of the elements is the correct choice. B and C is about increasing the intensity of the light, not wavelength of the light. Question number 43. If the distance between two lines in diffraction grating 2 micrometer, which is the slit spacing D, 2 micrometer, so calculate the number of lines per centimeter. So 2 micrometer, how many meters? 2 times 10 to the power of negative 6 meter, but it asks you lines per centimeter, not meter. That's why D must be written in centimeters, because it asks number of lines per centimeter. If asked number of lines per meter, you should continue with the meter. So it's going to be 2 times 10 to the power of negative 4 centimeter. Then I know that slit spacing is 1 over number of lines. The number of lines is equal to 1 over slit spacing. So 1 over 2 times 10 to the power of negative 4. So let's get it. 1 over 2 times 10 to the power of negative 4. 5,000. 5,000 lines per centimeter. So A is the correct answer. Light of frequency 10 to the power of 15 Hertz illuminates sodium surface, which is the frequency of the photon. Ejected photoelectrons are found to have maximum kinetic energy, which is kinetic energy maximum. Find the threshold frequency, which is FO, is the question. I'm going to use the Einstein's photoelectric equation, which is the H times F energy of the photon is equal to HF over work function plus maximum kinetic energy of the photoelectrons. I'm going to use the FO, so I have to transfer kinetic energy maximum on the side, HF minus kinetic energy maximum. So because FO is the question, if I divide both sides by H, I will find HF minus kinetic energy maximum divided by H. You can go further in simplification if you dare, if you want. This H will simplify. You can, so FO becomes HF over HF minus kinetic energy maximum divided by H. So F 10 to the power of 15 minus kinetic energy maximum is 1.78 electron volt, but we don't use electron volt. 1.6, we should convert it to joule. 1.6 times 10 to the power of negative 19 divided by H, which is 6.63 times 10 to the power of negative 34. So I'm going to use the calculator. Second term, 1.78 times 10 times 1.6 times 10 to the power of negative 19 divided by bracket 6.63 times 10 to the power of negative 34 is the second term. It is 4.2 times 10 to the power of 14. So I will subtract from first term. First term is 10 to the power of 15 minus answer. Result is FO 5.7 times 10 to the power 14 Hertz. So C is the correct choice. Which of the following summarizes Rutherford's model of the atom? So this question is asked before about Thomson's model. So the same choices are asked for Thomson. It's a standard test prep question. But this time they changed this Thomson model to Rutherford's model. It's the C. Electrons orbit the nucleus in a way that planets orbit the sun. So C is the correct answer for Rutherford's model. And question number 46, a photon in a laboratory has a 5 electron volt. What is the frequency of this photon? This is also a repeated question. 2015, exactly the same question is asked. So we are going to use again energy of photon. E is equal to h times f. F is the question, which is equal to E over h. E is given electron volt, but we don't use electron volt calculations. We should convert it to joule. 1.6 times 10 to the power of negative 19 divided by h, 6.67 times, 63 times 10 to the power of negative 34. Okay, 5 times 1.6 times 10 to the power of negative 19 divided by bracket 6.63 times 10 to the power of negative 34, close the bracket. Answer is 1.2 times 10 to the power of 15 Hertz. So this is the correct choice. So emitter base junction of the transistor is forward biased. Emitter base junction is forward biased. Collector base is the reverse biased. Remember, to properly bias that transistor, you have to connect them. Emitter base forward biased, collector base reverse biased. 48. An increase in the wavelength of the photon scattered by an electron relative to wavelength of the incident photon is called. This is the definition of the Compton shift. Compton shift. And 49. Maybe this is the only question a bit different than the rest in the first time asked question. In p-n junction is the contact between the p-type semiconductor and n-type semiconductor generates a depletion region from the movement of the charge carriers that goes to channel. P-n junction, which of the following is correct? A, B, C, D, D is given. So remember how depletion region forms. Let's talk about shortly. Yes, we are going to combine a p-type and an a-type transistors, parent semiconductors, p-type and n-type. So we know p-type has positive mobile charge carriers, they can move holes. N-type negative or everywhere negative charge carriers, which are electrons, mobile electrons. So when we combine them, this positive and negative charge move across the junction and combine. When they combine, they're formed a layer which is free of the mobile charge carrier because they cancel each other. Because mobile charge carriers on the p side transfer, this p side of the depletion region becomes negatively charged because positive charge leaves here and holes leaves in here and combine with electrons from the other side. And electrons, mobile electrons on the n side moves across the junction and then meets with holes. That's why the depletion regions n side becomes positively fixed positive charge stays there. They are all fixed. So fixed. These are mobile. So these are fixed. That's why electric field forms from positive to negative this way. So according to this, which choice is correct? When I check it, A is correct. Yes, A is correct. A is the correct choice for this. B is everything is, yeah, not everything is correct. So these charges are put in wrong place. Electric field direction is wrong. Mobile charge position is wrong. In C, mobile charge position is correct, but fixed charge positions are wrong. Electric field position is correct. D, fixed mobile charge positions are correct. Fixed charge positions are correct, but electric field direction is wrong. Yani A is the correct answer for this question. And last question. Which of the following is likely to be able to move or conduct electricity? An electron in innermost shell of the copper atom. Innermost electrons do not move. They are but they are moving in circular path, but they don't transfer from atom to atom, so they don't conduct electricity. Valence electron in a copper atom in a wire. Valence band at the same time as the conduction band. Remember, valence electrons conduct electricity. This is correct. An electron in the conduction band of a semiconductor germanium. Yes, for semiconductors, conductivity of electron starts in conduction band. This is also correct. So B and C are correct choice for question number 50. It is all for Industry 2023 first term questions.